Ready to start. VM. PLC.
PLC go.
ECC. DC go. FTS. FTS go. RTM. GSC. GSC go. OME. OME go. COM. Go. DPS. We're go. Go. Go.
Hey, welcome to NASA Edge.
An inside and outside look at all things NASA.
Hey, we're here in the Exploration Development Lab at Lockheed Martin. With us is Linda Singleton, who's the Orion Communications Manager. So tell us about this EDL facility.
Well, we're in the Exploration Development Lab, which is a 10,000 square foot facility located next to the Johnson Space Center in Houston. And we do a lot of research and development work here that helps us design new Orion spacecraft. But we also do a lot of integration and avionics work to help train our astronauts and our crew members and engineers on how we're going to perform all our test flights in the near future, as well as future missions to the space station and onto the moon.
Now, I noticed in this facility here we have a number of simulators. So what's the purpose of having multiple simulators?
Well, one of our simulators is the Orion docking simulator. And Jackie, I think you had some first-hand experience on that.
I did. It was great and very challenging.
It's a lot harder than it looks, and it helps our engineers design the docking mechanisms as well as the procedures that our crew members will use on orbit as they go to the space station and on to the moon. Well, Blair got some training in our full-scale Orion. It's called a low-fidelity mock-up, and that is where we do a lot of crew interface training, and we work with the crew members to determine, are the seats located in the right space in order to reach all the controls so they can properly manage the spacecraft.
Now, you guys are the prime contractor for the Orion vehicle. How important is it in terms of working with NASA and working with your partners as a collective team?
Well, Lockheed Martin, as you mentioned, is the prime contractor, and we work very closely with NASA. I always say we work lockstep with NASA, and we also have 5 major partners that we work with: Honeywell, USA, Orbital, Aerojet, and Hamilton Sunstrand to design and develop the vehicle. And then we also have 60 subcontractors located in 22 states across the country. Wow. So it's a huge program.
I am a little nervous. I mean, Jackie, I trust you that you're going to dock that vehicle, and I have all the confidence in the world.
Okay.
Right? I mean, everyone knows that. The whole audience knows that because they love you. My concern is the co-host. To put him in that low, I'm glad you put him in the low fidelity mock-up as opposed to the high fidelity.
Welcome to the real NASA Edge.
An inside and outside look at all things NASA.
So you notice I said real, because we're no longer, it's not simulated. This is the real show.
What are you talking about, simulated?
That was just a simulated interview earlier.
How'd you get on the set? We were just talking to Linda.
Yeah, what?
We just talked to Linda.
We just talked to Linda. What are you doing here?
This is a show about simulations. That's a simulation. This is the real show. How can it be
Linda
real
is the real deal.
Here?
You're a simulation.
She's no co-host. I'm the co-host.
Co-host is right here. You must be simulated right now.
But I feel real.
Well, while you figure that out, let's talk about what we're going to see today.
Yeah, actually, on the last talking to Linda, I'm looking forward to seeing you land the Orion spacecraft with the ISS.
I've got tactile.
Excuse me, trying to talk. I actually interviewed with Amber, and she talked to me a little bit about the Orion simulator. It was really exciting, a little challenging, but I learned a lot.
That was a simulation.
No.
Much like the interview earlier.
But she actually physically was real when I'm assuming it was real.
Yeah,
right?
absolutely.
I'll get it worked out. And I spent some time in a low fidelity simulator with Melissa, and that felt real to me, even though it was a simulator. So I'm all confused now.
Well, I tell you what, while you try to figure out if you're real or you're simulated, what I'll do is I'm going to go over to JSC and talk to Astronaut Lee Morin on another Orion simulator called the Rock.
Is he real? Is that real?
Yeah, Lee Morin, he's actually been in space, so he is real.
Oh, yeah. Boy, that's the real deal.
Hey, you're watching NASA Edge.
For real.
An inside and outside look at all things NASA.
I think, because it might be a simulation.
You okay?
I'm not. So, Melissa, I know that this mock-up is basically human factors, but it seems pretty sophisticated. What exactly are you guys trying to test from a human factor standpoint?
The astronauts are of different sizes and heights, so whenever they're in here in the simulation, you're testing for reach zones. Can they reach the displays? You know, your displays that you're touching are actually live, so can they...
Oh yeah, you just changed that.
Right, so can they actually see that? Can they touch it? Is it at the right height for them to be able to see where you currently are? Can you see out the windows properly? Yeah.
Yeah, positive, check, and check.
That's very important for human factors.
Just for the record, I'm seeing very well here. So you guys are doing a great job for 5.5 medianauts. You might want to put that in your report.
5.5 medianauts, I will do that.
Okay, good.
And this is where we're developing the simulator for the Orion spacecraft so that the crew and engineers can come in and actually test fly the
So astronauts actually sit here and practice?
They can come in.
Okay. What do you do exactly when it comes to all this?
With this, I'm the docking integrator on Orion.
Okay.
So basically, it's my job to ensure that we have safe docking to the International Space Station to Altair Lunar Lander.
So you get to see every little piece?
Yes, I get to be involved in a lot of subsystems, and I love it.
And you're an engineer?
Yes, I am. My background's in aerospace engineering.
Oh, perfect. So what am I looking at?
What you're looking at on this screen, this is our docking target. This is on the PMA Node 2.
What does that mean?
PMA is a pressurized module adapter.
Okay.
It's on the International Space Station.
Okay.
And this is the one you dock to when you're doing a V-bar approach, meaning you're coming in from the velocity vector.
Wow. Okay, great.
Up here on this screen, you can see the International Space Station. Here's our different system readings, so you can see our propulsion system and some of our flight instrumentation.
Okay.
These are to simulate the displays the crew would be able to see and work with while they're in the Orion spacecraft.
How long did it take to develop something like this?
It's been in the work for a couple of years now, and we keep trying to refine the fidelity and make it more flight-like as we develop our requirements and our better trajectories and approaches.
Well, if we come in here and we find that something is not working, then we have to go back to our design team and to our requirements and work with NASA, our customer, and try and figure out what is the best way to go about redesigning whatever it might be that's not working for the astronaut itself.
Do they get grumpy? Like if I went and said that's it's too far, would they get mad at me?
No, they would not.
Okay, well, because I don't want to make anybody angry.
No.
So what are you going to teach me to do?
I'm going to have you dock the Orion to the International Space Station.
Okay.
We're going to start by taking this hand controller. You'll go forward by pushing it in slightly, and whatever impulse you put into the system, it's going to keep carrying. The International Space Station orbits the Earth at 17,500 miles an hour. It's your target vehicle. Right now, you and Orion are the chaser vehicle. So you're trying to come at 17,500 miles an hour chasing the International Space Station, and you're essentially falling towards the Earth a little slower.
Okay.
You're going to have to probably keep pulling it up more, since the way orbital mechanics works, you fall to the Earth as you come in.
Okay.
And then you're going to want to approach very slowly and come in at about a foot per second, less than a foot per second when you're docking to it.
Less than a foot per second.
Because otherwise it could cause damage to the station.
All right, so some of the challenge you were talking about were reach. Well, I can do a pretty good job, and although these aren't real buttons.
Right, that's correct. That's just currently a mock-up.
If I can touch that knob, then I'm flight qualified, right?
Yeah.
See? Yeah, see, for the record.
So you are now flight qualified.
Well, I like this design. I'm ready to put my stamp of approval on it, if that's all right. What are some of the other things?
The lighting that you see right now is actually the proposed design for CEV.
Oh, so like in terms of color, temperature, all that stuff, visibility under all conditions?
Yes. Well, these displays, you can actually come up here and change what you are currently seeing.
How close is this to the actual, from a human factor standpoint, to being the actual Orion?
Well, I think we still have a few more design changes that we have to make upcoming, and we're not quite to our preliminary design review, which is very big for Orion.
You're 24 feet out from the station.
Okay.
You're looking out of the centerline camera view, out of the docking hatch, in this one to see the target.
Okay.
You're going to want to come down and line it up right.
I'm going up. I'm supposed to be going down.
You'll be following.
There's a reason I'm not an astronaut.
It's often when people think of docking, this is what they think of when you're already on the docking axis and just coming in.
Okay.
But the whole docking process starts about 6 hours prior when you do your
kidding.
rendezvous and proximity operations maneuvers. 9 feet out, looking good. See, you can see that X in the center. That's your stand-up cross.
That's my target.
Yes.
Oh no, it looks like
Slow
I'm
down,
gonna hit.
no. 2 feet out, slow it down a bit. Coming in
No,
fast
come
still.
down.
Bring it down, coming in fast, yeah.
Okay.
Foot and a half
Slow
out.
it.
Good speed right there. Bring it in, 1 more foot to go. Almost in, half a foot.
Oh no, don't go anywhere.
Almost in.
Yeah, that's right.
Congratulations, you have docked the
Thank you
Orion
so much.
spacecraft.
This is an excellent instructor right here.
We're in the lunar configuration for 4, right?
That's correct.
Is there any possibility of like adding a 5th?
Can you see how tight we're in here?
Well, what if you did 4, 5, 5 folks?
Well, then you start getting into your life support system, going all the way up to a lunar mission.
Interesting. Oh, so it's not just spatial. Then if you add another person, they actually consume more and...
They consume more oxygen, they consume more space.
Yeah, okay.
More consumables.
Well, it's clear. Yeah, clearly I got to think through some more issues here. I see. What are we doing here? There's something happening on the screen.
So this is where you're coming up and docking.
Okay.
So it's actually showing you your docking.
Oh, wow. I actually think I heard us dock
Yes,
out
it says
there.
dock down there in the green. So you actually got a green pop-up that came up and said you've
I'm docking. I'm not even doing anything. Okay, well, you're getting a good first look at the human factors of the Orion, and you're watching NASA Edge, an inside and outside look at all things NASA. Now, where's the launch button? That's what I really
I'm not going to tell you where the launch button is.
You're not going to tell me? I'm reading up here. Nothing
I'm not going to tell you where the launch button is.
Nothing says launch. That's not really fair.
Welcome back to NASA Edge.
An inside and outside look at all things NASA. I mean, how many hours do you estimate it would take an astronaut in training in the simulators to be ready for a mission, to be mission ready?
Well, if you combine the hours they're putting in now and all the design and development work, and then the hours they're going to put in actual mission training, it's hundreds of hours per crew member.
Okay, maybe hours doesn't work. Like weeks, months? I mean,
well, years.
Years. Okay, so it just seems to me that all the preparation that goes into this, you'd be spending so much time in these simulators that you might just get overwhelmed. And like when astronauts come back from zero gravity and they're dropping like groceries because they're used to being in zero gravity, you might get used to living your life in a simulator.
That's why these simulations are so important. Our crew that just returned from Hubble said that is because they had so many hours in the simulators and they had run these simulations over and over. Once they got on orbit, they knew exactly what to do, precisely when to do it, like clockwork. And that's what's critical, especially when we go to the moon, because we'll be on the moon for up to 6 months. It's not like the Apollo missions where they were there for a matter of days. So they've got to learn to live and work for a long period of time.
And if I'm not mistaken, you also then take the astronauts that have flown and have experience and have them give you feedback on developing more accurate simulators.
That's right. We have a lot of crew members who are over here in the lab regularly working on ingress and egress procedures to get in and out of the Orion crew capsule. They work with our engineers on designing the seat orientation and the visual display orientation. That's all done with our crew members. It's because, of course, they're going to be flying Orion, so we need their input.
When we're selecting crew members right now for shuttle, we have specific requirements. Are the requirements changing for the Orion?
Yeah, the mission's very different. Now, the beauty of Orion is that it's going to be a very adaptable and flexible spacecraft. So if NASA needs Orion to go to take a crew to the space station, Orion can handle that. If it needs to go to the moon or onto Mars or even to an asteroid possibly, Orion can handle those types of missions.
Wow.
So it's going to be a very versatile spacecraft, and it's also very adaptable as technologies develop through time. This is a new solar array technology that's actually used on the Mars Phoenix lander, and as those solar cells become more innovative and lighter and smaller, we will be able to upgrade the solar arrays in the future.
Is there an effort to move toward one ultimate simulator that covers all aspects of Orion flight?
This lab is what I call the predecessor to what we call the Gell, which is the Crew Exploration Vehicle Avionics and Integration Lab, and that will be housed over in Building 29. And we will be able to do all the risk and flight scenario mitigation here in this lab, so when we get it over to the Gell and the crew's ready to train for that first mission, everything's been streamlined and worked through, and it'll work like a charm.
Now, what else is going on in here? We worked on a couple of simulations, but what else do you have going on now in the EDL?
Well, right now in the lab, we're preparing for our first big flight test for Orion called Pad Abort 1, and that is going to test the launch abort system, which is a very significant crew safety improvement over the shuttle.
Well, great. Well, we need to head over actually to NASA and see how Chris is doing in the rock. So let's check that out.
So Lee, this simulation is pretty cool. Tell us about the rock.
The rock is the Reconfigurable Operational Cockpit. This is a NASA facility that has a very high-resolution virtual reality model, almost 1 million polygons of the space station, as well as a very good map of the Earth. It allows us to sit in the Orion cockpit made out of foam core and plywood, but it has the right geometry, and it allows us to exercise the dashboard and see where to place the windows and get an idea of what it's going to be like to fly this vehicle.
Now, when you were designing the inside of the Orion crew module, did you go back to the old Apollo astronauts to kind of get their input?
We did. We had several sessions with Apollo astronauts and asking them all kinds of questions about everything from lunar dust to what was it like riding the Saturn rocket, which is a different experience than riding the shuttle. It has much higher G-forces. So we had some big workshops with the Apollo astronauts, and they gave us a lot of insights. That was really a fascinating part of this job, to get to spend time with them. What
went into deciding you're going to have buttons, you're going to have electronic gizmos, is it going to be all digital?
But one of the big things was the weight and the taking advantage of modern electronics, and the displays are actually going to be 3 of these. This is a foam core mock-up of a piece of a screen that is actually used on the 787 jetliner.
Oh, really?
In addition to that, you also, when you're taking off, you're under so much gravity that you won't be able to reach those, so your hands will be here by your side. That's called Reach Zone 1, and so you have a thing that will be sort of like a mouse, as well as this stick will actually be down here by your side, and you'll be strapped into a seat that is very similar to a NASCAR racing seat. The windows are a very critical component, and this is basically how the crew sees outside the vehicle. Basically, the windows are designed to be optimized for a certain design eye point. And so this little ball is the design eye point. And so that if that's at the bridge of your nose, your eyes are in the position designed for this vehicle. And what this gives you is a sweep with all the windows, including the outer ones, are staggered so they line up with your eye. And the inner ones have the geometry so that they give you a good view of the horizon above, as well as some forward views. And once you design that, that is very expensive to change. And so this was something we actually started on the windows first, and then we have more time to do the rest of the cockpit. But the windows design what's called the outer mold line, or the outside shape. There will be a video on these screens. One of these areas on the screen, basically the screen is divided into 2 parts, and so this half screen would be a video repeater. And we have it here in a somewhat bigger format, but this is what it would look like, because there's a camera called a centerline camera right on the nose of the vehicle, which is forward. It would be right underneath where our feet are and forward. There's a little window in that hatch, and through that window there is a camera, and that camera is what you're seeing here. And that's very important to see your alignment as you dock to the space station. Docking to a space station is a very intricate series of maneuvers that starts thousands of miles away, and then finally you get very close. And so we're going to start about 200 feet out.
And you're still going to be sitting down, maneuvering it, looking through the glass, or will you be standing up to...
Yes, on the shuttle, of course, you're floating up around and people can float in. In this vehicle, you will be able to get up float up out of your seat and look at the graphics. And if you do that, you can look down there and see the visuals.
Oh, that's cool. Now, would there somebody there on station monitoring?
Absolutely, yeah, there would be. And people on board the station are going to be monitoring this very closely for several reasons. One is that you want to make sure that the station is in the right configuration before you bring a spaceship up to it.
Right.
And for example, some of the things that you can do, because the shuttle, as it moves in, it has jets that burn in different directions to keep its position in space or to nudge it in. So some of that exhaust can land on things, and so you want to make sure that things are folded up and put away so that they aren't damaged by that exhaust. So you can see that we're now starting to move the center line of the Orion, and it's focusing in on this docking port on the space station.
Now, are you using laser technology for that to line the systems up? Or?
There will be another device that is in that in addition to this optical camera, there's another camera system that creates an image that just the computer interprets. We don't actually see that image. It's a very sharp black and white image, but there's certain cues that are used to determine the velocity moving in and other information about the position. And some of that information actually would be displayed on this display as numbers. You can see on the top of this screen there will be an electronic procedures, and so this is where some of the things that were checklists in the shuttle or in the Apollo, these will be on the glass, and they'll actually interact with the displays to operate the spacecraft semi-automatically. The human will control it, but a lot of the work of finding the right display and finding the right switch, the workload can be done for you, and so that will make it more accurate, less likely to make mistakes, and make it easier to train. And this also removes quite a bit of weight, because the shuttle has hundreds of pounds, literally, of books that they take up, and those books will be electronic.
Now, as we approach closer to the ISS, I feel my heart starting to pump a little bit more. We're getting closer. I mean, how many hours would a typical astronaut such as yourself be in the simulator practicing?
You typically will spend hundreds of hours in the simulator practicing approaches and practicing on-orbit activities of various kinds, as well as the launches and landings. And you also spend a great deal of time, since I did spacewalks, you spend a great deal of time in a huge swimming pool. You spend about 10 hours of that for each hour in space, 7 to 10 hours. So we spend hundreds of hours.
So when you get up into space, after all the hours of training they have, it's sort of second nature to you?
Yeah, it feels like you're right at home, by the time you get there, because everything's familiar. There's nothing on the Earth that captures being in space. But the training folks here do a great job at creating slices of space so that you're real comfortable with pieces of it, and you have no problem putting all those pieces together so that you're prepared for the real experience. So this is the end of Node 2, and here's the hatch, and this is actually the place where the seal will be between the two spacecraft that will protect us from gravity. These pedals interact with others that we have on our side that fit together.
Looks like we're about ready to dock, and then once it docks, we make sure you have a good seal.
Make sure you have a good seal. One of the big things, particularly with a shuttle, is that you've gotten a good handoff, because something that you don't realize is that you've really got to control your position in space, your attitude. And that requires you to constantly nudge the spacecraft. And so the shuttle has small jets firing. They shoot about 37 pounds of force, and it nudges the shuttle to keep it in position. And the space station is doing the same thing. It's not doing it with jets so much as doing it with huge gyros that it internally pushes against the gyrodynes, and so that maintains its attitude. Now the problem is that once those two join, you don't want both of those vehicles trying to control the attitude, because they can start fighting each other, and that would be bad. And so what happens is that as soon as the shuttle docks, the space station needs to go into what's called free drift. So the space station tells the shuttle, you've got it, I'm not going to control us. You have to adjust your jets to control the both of us in space. And the way the crew knows that is that there's a big light that you'd see right overhead on the space station structure, and you want to see that light flashing, because that's a positive indication that the space station has gone into free drift. If it doesn't, you've got to immediately undock, because if you start getting into that fight where the two vehicles start fighting each other, that's
bad news. Okay,
yeah.
But will Orion be doing that as well, or will the station be controlling Orion?
Well, Orion is a much smaller vehicle, so I think it's less of a factor, but I'm not sure what the guidance folks are going to do with that.
Well, Lee, I want to thank you so much for giving us the opportunity to show us the rock, and you're watching NASA Edge.
Inside and outside look at all things NASA.
Okay, I just have to ask. We all have known Blair for a while. How did he really do?
Well, Jackie, just between you and me, the engineers thought the low fidelity mock was a little too challenging for Blair. So they're brilliant, and they've come up with a good low fidelity simulation he can work on by himself.
Oh, good. Maybe it'll make him feel better.
Yeah, I hope so.
Okay.
Rough re-entry. Check the tiles. Tiles are good.